Good morning. My name is Angelina Lopez, and I am in microbiology with Professor Caleb Bockora and Sarah Rogers. Today I'll be going over my midterm video discussion, and I just wanted to let you guys know that I did write down the questions of the PowerPoint so I don't forget it. So I will be referencing this, and then I have one PowerPoint slide that I wanted to share as well of a pure culture, Okay, so the first question says, what is a pure culture? A pure culture is composed of cells arising from a single progenitor. In the two common techniques that achieve that pure culture are called aseptic techniques. Aseptic techniques include streak plates and pour plates. All right, the next question says, describe the procedure for making a streak plate from a clinical specimen. All right, so you might ask what a clinical specimen is. A clinical specimen works in a principle of dilution. So it's loops of bacteria that get streaked on an agar plate and diluted within each streak to see the bacteria and how it goes down. All right, so right here on my PowerPoint slide, this is an agar plate of a pure culture. So these are the streaks. These are all bacteria. So there's 4 streaks that are each diluted. It goes from a lot to a little bit of stuff. Okay, so the steps of the steps of obtaining the pure obtaining the pure culture start by a process. So the first step that you're going to do is turn on the Bunsen burner. The Bunsen burner sterilizes the area so no bacteria is transferred anywhere, or, we don't get sick. All right, so after you turn on the Bunsen burner, you're going to pick up your loop. You're going to put it in the Bunsen burner until it turns red, and then you're going to let it cool. So the Bunsen burner is burning the loop to sterilize it. You have to let the loop cool, because if you don't and you put it in the bacteria, you could burn the bacteria and then the bacteria is dead and you have nothing to analyze. So you're going to put it in the loop, put the loop in the burner, let it burn for a little bit until it turns red, and then you're going to let the loop cool. After you're done letting the loop cool, what you're going to do is pick up from the inoculated area, and you're going to create little streaks on the plate that look like this. Little streaks with their close parallel streaks. After you're done with that, you're going to go ahead and turn your plate 90 degrees. Put your loop in the Bunsen burner again to sterilize it. Let it cool for a second. Pick up more bacteria, but from the inoculated area. So you want to pick up just a little bit and create more streaks just without overlapping it. So once you're done with that, you're going to sterilize your loop again, flame it in the Bunsen burner, turn it 90 degrees, and repeat those steps. Once you're done with that, you will come out with this pure culture. Once you're done with that pure culture, you're going to go ahead and put it in the incubator, set it at 47 degrees Celsius, and let it sit there for 24 hours. All right. The next question says, what is the desired outcome result of a streak plate? So the desired outcome or result from the streak plate is to obtain the isolated colonies from the inoculum by creating areas of a dilution of a single plate. All right, next question says, clinically, why is it important to make a pure culture from a clinical specimen? What do you do in order to treat a patient? Okay, so we're going to start with the first part of that question. Clinically, why is it important to make a pure culture from a clinical specimen? It's important because it facilitates the understanding and the treatment of the caused diseases. Second part says, what do you do in order to treat a patient? If you have no right treatment or no real pathogen, you can't treat that patient. This is why we obtain pure culture. So after you're done with that, after you're done incubating your pure culture, you're going to go ahead and take it out, examine the culture, see which bacteria it is resistant to. Whichever it's resistant to, of course, you wouldn't want to use, which is the bacteria that it's resistant to. And you want to find the bacteria, you want to find the antibiotic that it isn't resistant to, so then it will actually work. All right. And I believe those are all of the questions. Thank you so much for your time and have a great day.